All right, here we are, week 3, structured query language. So in the practical, you started off with structured query language, and indeed, if you may well, everything I tell you this morning, you may well already know, or most of it, if you've done most of the used cars practical now. So just a brief little trip into what is SQL and PostgreSQL, the relationship between the two, really briefly. Talk briefly also about COD's relational operators and how they fit into SQL and COD's relational operators, what the connection is between those. And then there's an awful long section on SQL syntax, and if you notice, if I see you nodding off, I do appreciate it. I can't remember when I was an undergrad, a master's student, I seem to remember SQL was regarded as possibly the most boring subject that there is. However, 20 years on, I think it's absolutely marvellous. So, you take things change. It is, as you probably know, well, you've probably heard of the sort of what we call data scientists, and if you look at the job adverts and things like that, the huge rise in the number of people or job adverts called data scientists, and depending on who you read or who you listen to, it's regarded as one of the sexiest jobs of the 21st century. And you as geographical information scientists are a flavour of data science, or data scientists. This is just this is sort of some kind of marketing slide or something like that. But notice this bit here, databases, the ability to manipulate, manage and understand data is at the core of being a data scientist. So therefore SQL, even though it may not be the most exciting thing, is one of these really fundamental, vital things that underpins a data scientist's work. If you can't manage and manipulate data, the information that you're trying to use, everything else becomes far more difficult. So it is very important. So we've met what is SQL. We met last week, structured query language. It's the definition, control, manipulation language supported by most relational databases in some form or fashion. It originated, like most relational stuff, at IBM, International Business Machines, in the 1970s in early implementation of cognitive models. They got back to the 1970s. It is a ISO and ANSI, ISO International Standards Organization, ANSI American National Standards Institute. You can look it up or something like that. As we can see, certainly the ANSI SQL standards, they get updated every 5 to 10 years. The latest update was in 2009, so it's an ongoing developing language. It is an example or a type of declarative language. So there are two types of programming languages we're going to meet. Well, two types of programming languages. Declarative languages and procedural languages. Declarative languages are languages where you state what you want to happen, or what is, and then the machine, you leave the rest of it up to the machine. So SQL is a declarative language. You tell the machine, the computer, what to do, you tell the database what to do, and it goes away and does it in its own sweet way. HTML, hypertext markup language, the language that the World Wide Web is written in, and we'll meet in the new year, is another declarative language. You declare the tags in your HTML file, and then it's up to the browser to interpret those and display them on the screen. In contrast, what you would think, or what might be regarded as normal programming languages, are what we call procedural languages. And procedural languages, you not only tell the machine what to do, you tell it how to do it as well. So that's what you would think of as a normal programming language, so Python, C, JavaScript, we'll meet later in the year. Those are all examples of procedural languages. Just bear in mind that this is an example of a declarative language. As I say, it exists as a standard, but how that standard is implemented varies across databases. So most relational databases implement most of the standards, I would say, and certainly the sort of there's your sort of normal set of standards, you know, the select commands, which tend to be reasonably standardized. It's the whiz bangs and the extras that tend to be and the less used stuff that tend to not follow the standards. What is Postgres? Well, Postgres is what we call an object relational database management system. Really, what do I mean by object relational? Well, it's a relational database that also has add-ins that allow you to store object-like entities. And we've got a whole lecture on objects and the object model later on in a few weeks' time. We'll be going into what objects are and what the object model is in more detail. Origins in the 1980s, in the Ingress project at UC Berkeley, California, and they subsequently commercialized the database product as the Ingress database. Sort of went out of business, not quite sure when, probably the early 90s, probably most likely, I didn't look that up. Oh, since mid-1990s. So basically the business didn't survive, but they opened the product, the software, the open source project. They made an open source project and made it freely available to the community since 1990. And it's a secure high-end database. Companies run their databases on Postgres. It's a fully functional relational database, which is has a commercial strength. It's not the most popular. It's not perhaps the most popular database. MySQL, which you'll be using in this new year, has about 54% of the open. This is just the open source market. Postgres is about 13%, and you can see there's a number of other databases, CouchDB, MongoDB out. This is only the open source, so it's not including things like Oracle and things like that. Pretty standards compliant, and has many extensions, including Postgres, and importantly for us, the PostGIS extension for spatial data follows the Open Geodata Consortium standards. Is everyone familiar with the OGC? No. The OGC, the Open Geodata Consortium, is a community of geospatial scientists, governments, organisations, big organisations involved in it, things like Esri and other GIS companies. And basically they define the standards for geospatial data. Just like international ISO defines standards at an international level, the OGC defines them for the geospatial community. Then the OGC may, for example, put their standards up to the ISO to become an ISO standard. So the world of standards is quite confusing. I can't say I'm an expert in it, but the same standard might be agreed by different standards organisations. But for geospatial data, it's the OGC who are the standards organisations. Look at their website and what they do. Postgres runs in Windows as what's called a service, or on Linux as a daemon, whatever it's called on. I've no idea what they're called on Apple systems. So the database server runs in the background, running Postgres and any other extensions or whatever that you might have in it. You've got a few funny arrows here. And then you plug in your various applications that allow you to manipulate the data and interact with the database. Basically, there is no sort of integrated interface, or the nearest thing you've got to an integrated interface onto the Postgres database is your command line interface. but generally you plug in these other client programs, pgadmin3, QGIS, to manage and manipulate the data in your database. So it runs in the background, and everything that you want to, if you want to do something with it, you have to get a bit of software, attach it to the, connect to the database. So that's all I really want to say about Postgres. So relational operations. And this should be COD's relational operators. So I mentioned that the relational model developed by COD is based on relational operators. It's also based on predicate logic, mathematical query, text processing, string processing functions, things like that. But at the core of the relational database is the manipulation of data in tables. And the relational operators, which were defined by COD, manipulate data in one or more tables. And these are these operators defined by COD are working underneath. Basically, they're the mechanics of the relational database system that SQL uses to perform its functions. Okay, so SQL is like a sort of higher level view onto these relational operators. And from the user perspective, the importance of the relational operators is that all rows are processed together, but the implementation may process rows individually. So as far as the user is concerned, you're processing at the table level, even though the underlying mechanics of how it's done may be done in normal procedural line by line, row by row operations. What you see is you deal with tables rather than individual rows. COD defined 8 relational operators in the early 70s, of which only 4 are really important for SQL and relational database functionality, so 4 of the 8. So I'm going to run through these really quickly. So these are COD's 8 relational operators. These are what underlie SQL, and sometimes there's a close match with what you do in SQL, and sometimes there isn't such a close match. So the first of COD's operators is select, or as it was first described, restrict. Select, very simple, limits the number of tuples in a table, a relation, on the basis of a specified attribute values. Very simple. Select item from relation where value is greater than some value. So this is implemented effectively in SQL as the where clause. Effectively. So it just limits the number of tuples from one table. Very straightforward. Project. Found an error in the notes, so I need to update the notes. I have updated the notes, I just need to upload them to the study space. I saw an error in the bit on projection, yesterday. So project just does the same thing as select, but on the basis of columns rather than rows. So it returns tuples made of a subset of columns in a relationship. So basically, you basically may be selecting the name field and the age field from your table. So you're just selecting columns, a subset of columns, rather than a subset of rows in your table. And how you implement it in SQL is a set of field names after the select statement. But we're going to do all that afterwards, all the SQL, so don't worry about this. I'm just trying to indicate where these particular relational operators sort of fit into SQL. The join operation, that's the third one, and this is, of course, is very important for SQL. It returns tuples, rows, from 2 relations on the basis of matching column values. Very straightforward. So we've got a student table or relation, we've got an attendance relation table, which classes students attended in, and we're going to link those 2 tables through the common student ID. Field. And join, unsurprisingly, is implemented in SQL in the join function between tables, the join clauses within a where. Those. Project. Also, product, not object. Product. A product function returns tuples from two relations that contain all possible combinations of tuples from the source relationships. So here's our table. These are just so we've got tables with single rows here, and these are the values in the rows. So we've got one value A, one B, one C. Table A, table B, we've got D and E. So we combine those two relations and return a third relation that contains all combinations. So we have A and D, A and E, B and D, B and E, C and D, C and E. That's a product function of those two. No SQL. It's not. This is one of the ones which isn't important in SQL. The union function returns all tuples from two relations that appear in one or both of the relations. So a union command, this is actually, these are all used in SQL, it's just a question of degree and how they're used. So here we've got all tuples that appear in one or both of the relationships. So A appears in both, B appears there, C appears there, E appears there. So a unique list from the two relations. Intersect returns all tuples that appear in both of the relationships. So in this case, we only return A because A is the only one that's in both of those relations. The difference is the only one which is non-symmetrical. So depending on which way your tables go, you get a different result. Difference returns a relation that contains all the tuples that appear in the first, but not the second of the relationships. So all the tuples in the first one, so if our first one is A, we return all the ones in the first one that are not in the second one. So A is in the second one, so we don't return A, we just return B and C. But if we do it the other way, the difference between B and A, the only record tuple in B that is not in A is E, the value E. So we return E. So difference gives a different result depending on which one you're comparing to the other one. Divide. It takes two relations. One binary meaning it has two rows, two columns, or one unary meaning it only has one value, and returns tuples of all values in one column of the binary relationship that match in the other column all values in the unary relationship. Another mouthful of the definition. So we've got a binary table A. So in the first row has two columns with values A and X, second row A and Y, third value A and Z, B and X, C and Y. Relation B has one value, only one column, so that's our unary relationship. And let me read the definition again. It returns tuples of all values in one column of the binary relationship, and one column in the binary collection that match in the other column all values in the unary relationship. So X and Y are in the unary relationship. Which ones do we have matches for both X and Y? Well, we have an X and a Y for A. We also have a Z for A, but that doesn't matter. B has an X, only has an X, it doesn't have a Y. C has a Y, doesn't have an X. So the divide result is A, because only the value A is associated both with X and Y, the two values in relation to B. And in SQL, if A is a table of suppliers and B of products, division would return a table of suppliers who supply all designated products. I'm giving you these just so you can see that those are the sort of functions, the CODS relational operators that underlie SQL. It's kind of having a peek under the hood of the engine to see the various bits inside, but frankly, we don't really need to know. You don't need to remember these in any way whatsoever. They're the sort of underlying mechanism by which SQL operates. It's good to have a little look and know about them, but beyond that, that's about it. Okay, so we're now going to plough into rather, I'm afraid it is a plough. It's not easy to write, to give lectures about code and things, and it's one of these things that's best done yourself in action, but hopefully there will be some use for this. Just to get you going. And some people find it more difficult to pick up the program than they don't probably find more use for this. Okay, so I'll try to sort of not get stuck too deeply in this, but we'll. Okay, so Postgres. One of the things to remember about Postgres SQL is a few rules, which can be really frustrating if you don't remember these rules because you're going to keep getting errors and you'll wonder why. So you may well have discovered these already. First of all, object names, and when I talk about objects in Postgres, you're talking about a table could be regarded as an object, a field could be regarded as an object, a trigger is an object, a function is an object, anything in the database can be regarded as some kind of object. So if you use capital letters to name objects, you have to enclose them in double quotes. If you use lowercase, you don't need quotes at all. This is just a sort of historical legacy of Postgres. So if you've got a relation or a column with a capital C, in this case called city, you need it in double quotes. You can't just type city without quotes. But if you're a lowercase, it's all in lowercase, you can get away without the double quotes. So city, lowercase is okay, and you can also put it in double quotes as well. Whereas single quotes are used for strings. And I get this muddled up all the time. I put a single quote around the field, the column name or the table name, and I put a double quote around the string, and then I go, bang my head on the table and change it round the other way. So strings are single quoted. So no strings, no single quotes, this is an error. You must quote your strings. That's obligatory. Semicolons. So in the SQL commands, sometimes I've put semicolons and sometimes I haven't, being the inconsistent person I am. Well, semicolons are strictly part of SQL. Every SQL statement should strictly end in a semicolon. So there should be a semicolon at the end of the code. But the reality is that you don't need to do it in pgadmin 3. If you just select one line of SQL and press run, you don't need a semicolon. However, if you've got a whole load of commands in an SQL file and you want to select them all and run them all together without having to select them individually, then you do need the semicolon. So if you've got a pile of SQL commands doing and you want to run them all together, you have to put the semicolon in. So only really required when you're running multiple commands, but it is strictly part of the SQL system. Code style. Now this is going to apply through all the coding you do this year, and we'll go into some more details when we go into JavaScript programming and things like that. We'll revisit code style. But it's an important thing to sort of start developing right from the beginning you start coding. You may think a 3-line SQL statement, how you write it makes very little difference, and you're quite correct. If I wrote that on all one line, it would be just as readable as it is there. But as your SQL and your other programming programs grow larger and larger and larger, using a sensible style and consistent style will help make your code more readable to yourself and to other people looking at it. So therefore it is very important that you start trying to organize your code, style it in a sensible fashion. And for SQL, first of all, I would suggest indentation, use of indentation. And there's no strict rules over this. Everybody does it in their own way, but there are a few kinds of general approaches for it. So here I've got the first line, then I've indented the second line. The indentation is purely optional, but certainly putting the select statement on one, the from statement, the first where, and then subsequent where statements on other lines makes the code more readable. So I would recommend try using some sort of indentation. The other one I use is I tend to write my SQL commands in capitals. They tend to, then it stands out from the stuff that's sort of specific to the database. So I tend to write things like, as you can see, selecting capitals from. But that's not essential. SQL we can do lowercase as well as uppercase. And in your pgadmin3, it's going to color code the select statements and the table names and strings so that you can tell them apart. But nevertheless, I think it's a good idea. And once you're writing select statements that are 20 lines long, plus with indented multiple queries involved in them, then indentation and capitalization can really help when you're trying to read the codes. Okay, so we'll just get going. We'll get to about 10 minutes and then have a rest on this break. So what I'm going to do is run through some queries and creating a database. Perhaps I should have tried to do this live, but you know, the risk is too high. So I thought we'd run through a few of the queries and give you more examples. One of the things is the more examples you see of SQL and other programs applied in different circumstances, that will help you hopefully understand how the actual functions work and how you use them. So it does no harm to see things used in different contexts. So first of all, creating a database. You've done it with a right click in pgadmin3, create database. You can also create a database, given that you've got permissions as your user, directly from an SQL interface. Here we are in Postgres. So in this case, I've started up. This is a brand new database. I've gone into that Postgres database, which is the default one that's provided. Got an SQL window up, and I want to create a new database that I'm calling World. Simple, create database, give it its name, World. Note, we run the query, we get a message returned at the bottom there telling us that the query returned successfully with no result in 3,262 milliseconds. No result? Well, what that means is we don't return, there's no tuple returned. So there's no table returned. What we have done is created a new object, and we've got a little message saying that has been successful, but it hasn't actually told us what it's done. We go to our pgadmin3 interface, we refresh, always refresh. Remember, pgadmin3 is garbage at refreshing itself. Always refresh it to see the results. As you can see, I've created a new database called World. By default, it is in the public schema. So schema, remember, is like sets of folders that you can store your tables and everything else in to sort of help organize your database. The public schema is the default one, so if you don't specify a schema, everything goes into public. And as you can see, it's an empty database. All these different types of objects, some of which I have no idea what they are. I have no idea what FTS configurations is, for example. Never seen those. Totally empty database. And here's the full SQL kind of that's behind that database. Create database World with owner. So the owner is Pegis, who created it. The encoding, how the characters are encoded in the database, etc., etc. So I'm going to create 3 tables in this database. First one called City. This is going to be a database of cities, countries, and their languages. Really, I mostly just use cities, but the other ones are here as So we can create our city table, which we're going to load up some text into here. So with our command create table city, the name of the table, then we have on the next lines we have the names of each of the fields that we're going to create, the name of the field, 5 fields, ID, name, country code, what type of data type is going to be in there, integer, text, a character of length 3, so just a 3 characters for a country code, district text. And as you notice, we can also put constraints on individual columns as part of the field definition. So all these have been set to not null, which means we can't have, it prevents any null values being loaded into those fields. That's a constraint on each field. Also one called country. As you can see, this is quite a bit larger. It's got quite a lot more fields. Notice we've got a few other types of data types, real, which are a type of decimal, small integers. Notice that this in-depth year, which is in year of independence, is not in as a date field, it's in just as an integer, so as a number, not a date. What else have we got here? Oh, the other things we've got here is we've got set a constraint on the continent, country continent. So we've got a field called, where's that? Country continent text, yeah, third one down, okay. The constraint, so we're setting a constraint on the database. The constraint is called county continent check. So that's the name that's associated with that constraint. And then we've got a check here, and what we're going to check is that the continent is equal to Asia. These double colons text, what that is the double colon and then the name, a data type afterwards is what's called, what's the right word for it? Casting. We are casting this string to a data type of text. It's a conversion. Okay, but you're saying, well, that's a string. Well, yes, it is a string, but there are lots of different data types that string for strings: varchar, char, text. So whatever the default, and I don't know what the default data type for a string in Postgres is, but if we want to make sure it's a text data type, then we can put these double colons and convert it into text. Some functions, for example, might work on a text field but wouldn't work on a varchar field. So you might need to cast it, the data type, from a varchar to a text, because that's the data type taken by a function. So this is a conversion. So all we're doing is testing whether the continent has the value Asia, Europe, North America, Africa, Oceania, Antarctica, South America. Any other strings that we try and enter into the continent field will be rejected by the constraint check. Okay. Defining a more complicated constraint form. This is, it's a good way of defining constraints, check constraints. But notice that you would have to go in and redefine the table definition, or update. You need to alter this constraint check if we had a new country or a new continent was discovered. If we discovered the lost continent of Atlantis, for example, we need to add it at Atlantis, we have to update our table definition. If we've got some list that's got changing more often than our list of continents, I don't know, possibly a list of people or some other list that's more dynamic, we might actually have wanted to do a constraint that looked up data in another table and said, does it match the values, a foreign key effectively. But so there are different ways. So there are different ways of implementing checks. So, yeah. No, probably not. There's no, a drop-down list is a different, I mean, a drop-down list would have to be implemented in the interface to pick up, you could write an interface that picked up this list of checks and provided them in a drop-down list. If it was lowercase, I don't think it would go in. I would have to check that. I would have to remind, I can't remember exactly over that, whether that. Yes, yeah. So clearly, for a database manager, this is fine, they know where to look. But for an everyday user who's trying to deal with the interface, clearly they need to know what the acceptable value's in, and what you would do probably is provide some kind of pull-down list or something like that to provide that information. Third one, create country language table, very straightforward. Notice, what have we got? One thing is, notice here is that we've double quoted the language field, the creating of the language field in the country language table. Now this is double quoted because all programming languages have things called reserved words. Words that are part of the language itself, like select in SQL, select, part of the language, where is part of the language. And language is part of the language because you can load up all sorts of, you know, it's an international database, we could load up Chinese, we could run Postgres with Chinese, we could run it in. Also it's used for programming languages as well, so Python language, PLSQL language. So language is what's called a reserved word in Postgres. There is an example of a reserved word. And reserved words, if you want to use them not as reserved words, but to refer to other things, need to be double quoted as well. Or did at one point need to be double quoted. It's interesting. Sometimes they seem to be need to be double quoted and sometimes they don't. For example, later on you'll see we've got a field called name, which also appears to be a reserved word according to Postgres, but it doesn't need to be double quoted in SQL queries. So bear that in mind. These reserved words may or may not need to be double quoted. I think the double quoting is one of these things that's been dropped as new versions of Postgres come along. It's something that I'm slowly removing. Because in this context, you know that language is referring to a field or a column, not to the reserved word language because of its context, where it's being used. So bear that in mind. Sometimes you might need to double quote these reserved words. And after running that, here are our three new tables in Postgres. Nothing greatly new there. We can select the columns and we can get the information behind various columns. We'll just get the data loaded up and then we'll have a little have a short break. Okay, CSV files. You did this probably last week. I should have done if you're up to date. So we've got 5 columns, our 5 fields for our city table. We've got them as a tab separated file, so each value. So this is the ID field. This is the city name, the name. This is separated by a tab. But in your examples, we use for the used cars, we use commas to separate the values. These are separated by tabs. We did this. We copy. We can use the copy command. Copy into city. This is the fields, the order of the fields that we're going to load up. So the first column in our table contains the ID field. The second column contains name. The third one contains the country code. So we could load this data. If our country code was in the first column, we just move this to the first one and move IDs to whichever column IDs. So this is giving you the order of the fields in the file from this location. This E prefix is just tells the computer that this is a raw text string. Just do it. It just tells the Postgres to read this as raw text. Then we have the path to our file. The double slashes are what, instead of single slashes, we use double slashes in here because we have to do something called escape the slash. So the slash in a string may be read is another like it's a sort of reserved character. So it means something, slash. It's used to mean something. So if we want the computer to interpret our slash just as a text slash as opposed to how it would interpret a slash otherwise, then we have to escape it, and the way to escape characters in this case is by putting a forward slash in front of them. So that's why we have the double slash. I think in the notes I go into some more details on these. Paths can be a bit different ways of writing paths in Linux and Windows, and there are ways, this is the way that should work, I think, on both Linux and Windows operating systems and things like that. So that's why you have the double slashes, basically. So get another example of this sort of escape character. Then we have the name of the delineator, the delineators command. Again, we have the T to make sure it's raw text, it's read as raw text. And this /T is how you define a tab, /T. So that means a tab. /N means a new line. So there's these various codes that are used throughout text files to denote things like tabs and line endings, and these are hidden within the text file, so you don't actually see them, although you can sort of expose them in your text editor so you can see these /Ns and /T. So that's meaning it's tab. We run it, we get our result, it says it's worked, we've loaded up 4,007 loads. We look at the database. Whenever you do commands and load commands and queries, it is extremely good idea to look at your results, because you often don't get exactly what you think you're going to get. And often that doesn't materialize if you don't check the results carefully, or then these results you may find interfering later on if you're writing an application. You may find that these problems don't emerge until several days, several weeks, several months later. And they can be really quite serious, because you might have to go back and redesign the fundamental underlying bit of your code, and everything else is dependent upon it. So it is very important that you check that things have loaded in as you think they're going to load in, because they often don't do that. So here's just an example. Here's this country table, and we've got it loaded up. Here it is, loaded up into thing. That's what this line for American Samoa looked like in the text file. And really, I just want to point out here, this /N is being used in the text file to indicate a null entry. So here, American Samoa has independence year, doesn't have an independence year. American Samoa is not independent country. Therefore there is no value in here. Null, and a /N is being used to represent a null here. I don't think that's not required. A tab with no value and then another tab would do exactly the same. But sometimes in this case they use the /N, like they use /T for tabs, /N for null value. Also, if you look at the data loaded up, well, there's a few oddities in here. Afghanistan /Al Jazeera /local name. Well, I think that's more than one local name. Here, look at that. We've got a head of state. Instead of a null, in this case, we've had an empty string loaded up. Or actually, probably what we've had is, that might even be two quotes as text. It may be text of two quotes, or it may be an empty string. You need to know what that is and investigate what that is. So it's always a good idea to have a scan through through your file and to see that everything is loaded up correctly. Sometimes you've got extra data in a line of file, lots of other things. Do look at. And we'll just add those primary keys. So also this table, so we've got loaded up our 3 tables. I'm not going to show you the other tables. And then we can add our primary keys. So our city table, we add a constraint. We call that constraint city primary key, P key. We set it as a primary key, which if you remember is no nulls and unique. And the field name that's the primary key is ID code. Note this one, country language. The primary key is a composite key, can consist of country code and the language field. So that's a composite key. So we're adding a composite primary key onto country language. There we go, we get these constraints. Here's the constraint that we just added. Added into the city table definition. Foreign keys, 2 foreign keys, 1 in country language. Again, we add the constraint, the name of the constraint, country capital F key, foreign key. It's a foreign key on capital that looks up city ID. And if we remember what a foreign key, the constraints of a foreign key are that the value must be, so the value in capital in the country table must be match an ID in the city table or can be null. So that's a foreign key constraint. It can either be null or match one of the values in the table that it references. There's our new, so now we've got our primary key and our foreign key defined on our table. And you can see that the create table definition, we could create this entire table in one shot with this SQL query. Okay, so this is the SQL that would create that entire table. No need to do the things individually. We could define the whole lot in one SQL query. We've loaded the stuff up. All right, I really will finish in a minute. I'll have a coffee break. So we load the stuff up. We need to do a bit of maintenance. Every time you load data up, every time you update data in a database, what happens is that the database, Postgres, uses a table, internal table called PG statistics to plan its queries, how to undertake the queries. PG statistics contains things like the number of rows in the table and all this various statistics on the table which help the query planner optimize the query so that it runs as fast as possible. But PG statistics is not updated automatically. You can set it to update automatically on some time thing or something like that. So what you do to update PG statistics following data load or update, it's a good idea to run what's called the analyze command, and that basically goes through, works out the statistics and updates the PG statistics table. Okay, if you've just entered 1,000 records, it's not going to make a difference. If you're talking about millions of records or thousands of records, yes, it's going to play with that. So do run analyze on a periodic basis on an active database. The other thing is that that deleted and updated records are not automatically removed from the database. They kind of sit there, they're kind of just sort of linked out, they're sort of hidden rather than actually deleted from the database. So if your database slowly increases in size, the amount of data stored may be the same, the live data, but because you've got these old and updated records in the system that haven't been removed, you need to occasionally do a garbage collect, and you can use the vacuum command, the vacuum full in this case, or just full just means do the entire database to clean out these updated records. While I'm talking about updates and deletions, every action on a relational database is instant and permanent. There is no such thing as an undo button or an undo command. Once you've done it, you've done it, and you've got to rebuild. If you've done a mistake, you have to go back and reload your data or whatever, undo your change. So all changes are instant and permanent. bear that in mind. So think before you press your button. Okay, right, we'll take 10 minutes and then we'll go into the meat of the select queries. Okay.